Hello there, Mr. Sutton here, bringing you the Algebra 2 10-1 Part 1 homework solutions on right triangle trigonometry. For this problem, we're trying to find this missing angle right here, and we have these two sides. So we're going to bust out our SOHCAHTOA functions and see what we can do with this. Now I notice here that I have, based off of this angle, I have the opposite side and the adjacent side. So OA, that's TOA out of SOHCAHTOA. So I'm going to set that up with tan of theta equals opposite over adjacent. So specifically here we have tan of our angle, x, equaling our opposite side 10 over the adjacent side 22. In order to get the angle, I need to take tan inverse of both sides of this equation. So that ultimately means that x is going to be tan inverse of 10 over 22. Let me pull up the calculator and run those numbers. So let me do tan, and then a little -1 up here makes it the inverse, and then I'll put parentheses 10 over 22 in there, and that comes out to 24.4 degrees. For this problem, I'm trying to find this missing side of a right triangle, and I've got one more side, an angle, so I'm going to use SOHCAHTOA. And let's see here. Based off this angle, I have the adjacent side. I've also got the hypotenuse, so that gives me ka out of SOHCAHTOA. That means I need cosine for this one. So I can write cosine of theta in general equals adjacent over hypotenuse. So that means cosine of my angle, 30 degrees, equals the adjacent side x over hypotenuse 8. Now to solve for x, I have to multiply 8 by both sides. So 8 times the cosine of 30 is going to give me my answer. Let me run that on the calculator. So let's do 8 cosine 30. And all this time it's in degrees. That's the nice thing about the Desmos scientific calculator. It defaults to degrees. So that's going to be 6.9 roughly. To find this missing side, since I have one more side and an angle, I'm going to use some SOHCAHTOA. Looking at my angle of 60 degrees here, I've got the opposite side from that, or at least I'm looking for that, and I've also got the hypotenuse. So opposite hypotenuse, OH, that is the SO part of SOHCAHTOA. So that means I'm going to use sine equals opposite over hypotenuse. So I can write sine of 60 degrees equals opposite side x over hypotenuse 6. And in order to solve for x, I just multiply both sides by 6. So 6 times the sine of 60. Let's see what that comes out to. So 6 sine of 60 comes out to 5.2. For this problem, we're looking for this missing angle. Now we've got the hypotenuse and also the adjacent side. So that means I'm going to need cosine, ka. So I can write cosine of theta equals adjacent over hypotenuse. So cosine of x equals adjacent side 7 over hypotenuse 12. And to get the angle, I need to do cosine inverse of both sides. So x is going to be the inverse cosine of 7 over 12. So if I run that on the calculator, I do cosine, exponent, -1, and then come back down in parentheses. 7 over 12 comes out to 54.3 degrees. In order to find this missing side x, since I have an angle and another side in a right triangle, I can use SOHCAHTOA. So I've got, based off this angle, I've got the opposite side and the adjacent side. So I need TOA, tangent, equals opposite over adjacent. So I can write tan of 45 equals opposite side x over adjacent side 8. So then 8 times the tan of 45 is going to give me my x, and I can run that on the calculator. I happen to know tan of 45 is 1, but let me run it on the calculator. So 8 tan 45 comes out to 8. 8 times 1. For this problem, I'm trying to find the missing angle over here, and I've got the hypotenuse and the opposite side. So opposite hypotenuse, that's O, so that's going to be SO from SOHCAHTOA. So sine equals opposite over hypotenuse. So I have the sine of the x that I'm looking for, equals the opposite side 14 over hypotenuse 16. And then I need sine inverse of both sides to get the x. So x equals sine inverse of 14 over 16. So let me do sine -1 on Desmos here, and then let me do 14 over 16, and that comes out to 61.0 degrees. On this problem, they want us to solve the triangle, given the diagram and the two pieces of information here. Let me start by actually labeling my diagram. So angle A is 27, and side B is 9 right there. And now I'm going to find the other missing sides and angles. Now I don't have to find angle C because that's a right angle. I do need to find angle B, however. So because I've already used up 90 degrees over here, that means that there's 90 left over for these other two angles. So that means B must be 90 minus the 27, the complementary angle. And that comes out, I believe, to 63 degrees. I'm also going to find sides A and C. And I'm going to use the 9 and the 27 to do both of these because I'm guaranteed that these two pieces of information are correct versus anything I might find along the way could have gotten it wrong. So based off of this information, side A is opposite the angle they gave me, opposite 27, and side B, which I have, is adjacent. So opposite, adjacent, that's going to be the TOA part of SOHCAHTOA. So I can use tangent equals opposite over adjacent to find side A. I can write specifically tangent of 27 degrees equals opposite side A over adjacent side 9. And then to get A, I just need to do 9 times the tan of 27. And then if I run this on the calculator, 9 and tan of 27 comes out to approximately, they wanted nearest hundredth actually, so 4.59. All right, let me go ahead and find side C now. Since I have sides A and B, I could use Pythagorean theorem to get it, but I'm going to use SOHCAHTOA again because, again, the 9 and the 27, I know for a fact those are correct. So let me, let's see here. If this is the hypotenuse and 9 was the adjacent hypotenuse based off of this angle, that's cosine of theta equals adjacent over hypotenuse. So cosine of 27 now equals adjacent side 9 over hypotenuse C. Now to get C by itself, I have to multiply it to this side and then immediately divide by cosine of 27. So I have C equals 9 over the cosine of 27. Let me go back to Desmos to figure that out. So let's do 9 divided by cos 27. And that comes out to about 10.10, so 10.10. On this problem, I'm trying to figure out all the sides and angles of this triangle, given that angle B is 16 and side B across from that is 14. Let me start by labeling the diagram. So here's angle B, 16, and side B over here, 14. Now I can immediately figure out the other angle because I know these two angles have to add up to 90 degrees since we've already used up 90 with the right angle. So I know that angle A then, angle A, there we go. Angle A is 90 minus 16, so that's going to be 74 degrees. And now to get side A, which I'm also missing, I'm going to use, for side A and C actually, I'm going to use this angle B that they gave me and side B here. And I'm going to use them both times because I know that these are correct pieces of information. I'm not going to use any of the other things I find along the way, although I could if I were confident in those answers as well. So based off of angle B, I've got the opposite side over here, and I'm looking for the adjacent side. So opposite, adjacent, that's TOA, tangent, equals opposite over adjacent. So tan of 16 degrees equals opposite side 14 over adjacent side A. And then to get A by itself, I have to basically switch the A and the tan of 16 and run those numbers on the calculator. So I've got 14 divided by tan of 16, and all this is in degrees mode. That comes out to 48.82 if I take it to the 2 decimal places there. Let me also find side C now. So this was the hypotenuse, and again, I've already got the opposite side. So if I'm dealing with opposite and hypotenuse, that's O, that's SO from SOHCAHTOA. So sine equals opposite over hypotenuse. So sine of 16 equals now 14 over hypotenuse C. So I'm going to do something similar that I did over here. This time I'm going to switch the C and the sine of 16. So I have 14 over sine of 16. And let me just go here, and I actually already have 14 over tan of 16. So let me just replace tan with sine, and that gives me a different answer of 50.79.